In this tutorial, we're going to show you how to create the toolpaths for the Rocket Nameplate sign you can see on the screen here. We will start by closing this finished project and opening up the file that contains just the vectors that were created in a previous vector drawing tutorial. This can be found as a related video on the web page. So I'm going to file close now just to close down this project, and we're going to open an existing file, and in this case it's going to be the Rocket Nameplate vector drawing.crv file. So I'm going to select that now and open that up, and we can see that we have a number of vectors drawn on the screen. We have an inner and outer border, we have 4 drill holes, and then we have the text curving through the center. Now, for ease of use when we come to machining, I'm actually going to group some of these vectors together so I don't need multiple selections. I know that I need to pocket between the rocket text and the inner border, so I will pick the outer border and shift and pick the text, and then right mouse key to group objects. Now if I deselect, I can come back and select both these entities with just one single click. I'll similarly do the same with the 4 drill holes, but rather than using the menu, I can actually hit G on the keyboard and that will group the items. So once again, if I deselect now and reselect, I've just used one click to pick those 4 items. So we're going to move away now from the drawing menu and come across to the machining operations. And the first thing I need to do really is to look at our material setup. So selecting the set button, we can see that our thickness is set to 1/2 inch. Our XY datum is in the lower left hand corner. Our Z0 will be from the material surface, and we've got suitable rapid and home start positions. So with that, I feel comfortable that I can go ahead and start creating my first toolpath. So the first toolpath we're going to create is the pocket between the rocket text and the inner border. Well, I don't need to select both the vectors because they're grouped, so I'm going to singly pick that item and come across to the pocket toolpath and just take a look at the settings that we have here. Now our start depth is going to be 0 from the top of the block. Our cut depth is actually just going to be down by 1/8 of an inch to 0.125 of an inch. Okay, now the tool we're going to pick, if we select that now, we've got a range of different tools there, and I'm going to pick an 1/8 inch end mill, and that will load obviously the settings including the pass, depth, step over and speeds and feeds. So I'm going to select that now, and I now need to move down to the way I'm going to clear that pocket, whether I want to just raster XY or use an offset strategy. And given obviously the curved nature here, I think an offset strategy would be advisable. And then moving right the way down, we're just going to give this a name now, which is going to be called pocket text, and we can calculate. So we can see that now drawn on the screen and showing the sort of 2D lines for the toolpath. I'm going to go ahead now and simulate that so we can see that being cleared away. And I'm going to come up to the toolpath color and just give that a nice sort of dark red color. So I'm going to select that now so we can see exactly the area that's been cleared by that area clearance tool. Okay, well the next stage that we really need to look at is how to go about adding some texture into the sort of dark red area you see on the screen. So I'm just going to close out of that form now and come back to a sort of a tiled view so we can see the 2D and 3D view. So I know that this is the same sort of area I want to cover, so I'm going to come across now to the texturing toolpath, okay, which will create a really nice sort of scalloped 2.5D toolpath. I'm going to pop that open now, and we now need to decide what tool we're going to be using in this region. So in this case, we're going to be using just an 1/8 inch ball because obviously we're going to look to create some nice scallops on the surface, so we don't use the end mill, so it's an 1/8 inch ball. Our start depth is not going to be 0, but it's actually going to be at a height of 0.125, which was the depth of the previous pocket toolpath. So we're starting from where that essentially finished. Now the next stage are the settings that we're going to be using for the texturing toolpath, and these are covered in a related video. So these are currently set for this particular project. So we've got a cut depth of 30 thou. We've got a cut length, in other words the sort of length of the scallop is 1/2 inch. We've got the overlap specified, and of course the step over, etc. And we're going to move straight back down now, and this is going to be called texture pocket, and we're just going to calculate that now and we'll see what we get. So we can see the toolpath shown in the 3D view, and I'm just going to show that now in full size, and we'll just play that through. And you can see that it's not quite as I expected. I was hoping that we were going to get it just in the red region and not sort of violate the border or the text, but clearly that has happened. So I'm going to undo that now and think about how to address that. So I'm going to pop open the toolpath again. Now all my settings are correct, but the one thing that I need to consider here is the boundary offset, because currently the tool is cutting onto the border for this texture toolpath. So I now need to apply a sort of an allowance to stop the tool before it gets to the text and before it gets to the border. Now, given that the radius of the tool is 0.0625, essentially, well, half the diameter, then I need to give a boundary offset of just a little greater than the radius. So I'm going to give this 70 thou, and now just recalculate that toolpath. Okay. And now I'm going to replay it, and I'm just going to change the color as well into the dark red and just preview that toolpath. And we can see now that that's given us exactly the effect we've got. We've got this sort of textured toolpath look on the screen, but we are not getting it violating the border or the text. So that's ideally what we want. Okay, so the next stage is for us to consider the drill holes in the corner. So I'm just going to close out of the preview form and just show this tiled in the 2D and the 3D. And we're going to look to create the 4 drill holes just outside the inner border. So I'm going to select that now on the screen. You can see that it has picked all 4 holes. I'm going to come across to the drilling toolpath, and we need to specify a start depth of 0 and a cut depth. Now, if I didn't know the actual depth of the material or thickness of the material, I can just type in Z equals, and that will give us the cut depth. The tool that I'm going to use is an 1/8 inch end mill, so I'm just going to select that from my list. In this case, I'm not going to be using peck drilling. If I was maybe cutting to a deeper depth or with a smaller tool, this may be considered. But I'm going to come down now and just specify the name, in this case drill holes, and we're just going to calculate that. So we can see that shown in both the 2D and 3D, and I'm just going to simulate that in 3D now, and we can see those 4 holes that have been added. Okay, so moving on from here, we need to look at the cutout pass that we're going to put around the outside. So I'm just going to close out of the preview now and come back in and select from my 2D view that outer border and come across to the profile toolpath. Now our start depth once again is 0. Our cut depth is the full material thickness, which is 1/2 inch. The tool that I'm going to be using is the one specified, which is the 1/8 inch end mill. Okay. And by the nature of the tool settings, that will give us 4 passes. Now we need to decide whether we're going inside, outside, or on those vectors. Of course, we want to protect the shape, so we're going to go outside that vector. Okay, and then we need to come down to a very important part, which is to add tabs, because of course, bearing in mind that this may just be clamped on, then we need to make sure that the part does not sort of break away loose whilst we're cutting around the border. So I'm going to specify to add some tabs here. So as I click add tabs and then go to the edit tabs, we can see now that I can come across to my 2D view and then start adding where those tabs need to be. In this case, I'm going to go to the form on the right hand side and specify 4 and add those tabs, which is shown on the screen. And of course, I can then just hold my left key down over one of them and just to move them. So I'm just going to move them into slightly better positions. Or if I wanted to delete them, I could simply click on it and then click again to add where I wanted. So in this case, I'm adding 4. If I close that out now, in terms of the size, these will be sort of 1/4 inch in length and just 100 thou in height. Okay, so that's the size of the tab that will be left. And in this case, I'm just going to call this, rather than profile, I'm going to call it cutout. And now we can go ahead and calculate that. So if we then zoom into the 3D view, we can see here the lifting of the tool over the tab. So we can see we've got 3 complete passes, but on the final pass we are leaving some material there so that we can then break that away and clean that up to create the finished part. But essentially this is to protect the fact that we need to make sure the part stays in position through the whole of the machining process. Okay, so we're just going to expand that up now, and we can go ahead and play that, and we can see that on the screen that we've created that cutout toolpath, but protecting it with the 4 different tabs on the 4 edges. Okay, so the next stage really is to consider posting this out as G-code. So if we close down the form now, the Save Toolpath icon on the right hand side there will then pop open the ability to start saving these out as G-code files. We have a full list of post processes, and of course with these particular 4 toolpaths, 2 of them do share the same toolpath, same tool, which is of course the drill holes and the cutout. So I could select those 2 there and then possibly post those out together. And I think even the pocket text was using the 1/8 inch. Okay, you can see that there. So those 3, and we just need to maybe specify the order of those and then save those out, and we can create a single file that can then be run rather than 3 separate files. Okay, so in this case I'm not going to be saving out any of the G code. It's something that you can do for your own particular machine with your own particular tools and settings. But what I will do to finish off this project is save this now. So I'm going to do File Save As, and I'm going to save this as the Rocket Nameplate 2.5D Toolpaths.crv file, and that means that I can later come back, reopen it, and post those toolpaths out at a later point.